Good morning, students. In the previous classes, we discussed about the power of lens, and we found that the power is defined as the capacity of uh, a lens by how it can converge or diverge a ray of light that is falling on it. That is the capacity of converging and diverging of a ray of light or beam of light falling on that particular lens is called a power of lens. We also found that the dimensions, units of power of a lens is going to be diopter, and in what case it is positive, in what case negative, we have discussed. Today we are going to discuss a topic related to that, that is combination of lenses or combination of two thin lens. Combination of two thin lens. If you combine two thin lens, what is going to be their equivalent focal length? That means we can also say combined focal length, or equivalent focal length. Combined focal length or equivalent focal length. That we're going to discuss today. That is our topic, combinations of two thin lenses in contact, and what we're going to derive from them, the combined focal length or equivalent focal length for that type of lenses we're going to discuss. You just write the headlines. Now for that we need two lenses to be combined. If I take two lenses, they are very thin lenses. If I consider two thin lenses in contact, that means suppose I have taken here two lenses that are in contact. Suppose like that, I have taken here two lenses. This is lens number 1 and this is lens number 2. This is focal length f1 and this is focal length f2, and they will have a common principal axis. They will have a common principal axis like that. Understand? So I have taken two lenses which are in contact, respectively L1 and L2, and their focal length is f1 and f2, and they have got a common principal axis. Now what will happen in this case? If I consider that an object here, and from this object a ray of light is coming here, and if I assume that this lens is not available now, am I clear? If I consider that lens number 2 is no more available now, then what will happen? This ray will refract like that, and this ray will create an image, suppose somewhere here. This is going to be the image, suppose this is I. That means I is the image formed by this object for the lens number 1 in the absence of lens number 2. I hope you can get it. Understand what I have assumed for the beginning? I have assumed that lens number 2 is not available here. In the absence of lens number 2, lens number 1, for lens number 1, this object has created an image, the image for this object is I. Understand? Now if I see in this case, so here we know that, what we know? We know that lens formula is, what was lens formula? 1 by f is equal to 1 by v minus 1 by u. This was the lens formula. Understand? Now in this case, if I consider this is the optical center for this particular lens, and this is optical center for the second lens, though I have assumed that lens 2 is not available now. Now if I consider that, and we know that the length formula is 1 by f is equal to 1 by v minus 1 by u. Now if I apply this length formula for the first length, so you can write now for the first length. What will happen for the first length if I apply? For the first length, if I apply this formula, then focal length is f1, so I will write 1 by f1. Understand? 1 by f1 is equal to, what is the image distance for the first? This is 1 by v. V is going to be your image distance. So image distance for the first length is c1i. c1i minus 1 by u. 1 by u is going to be your object distance. So object distance is going to be your what? c10. This is c10. Let us consider this is to be number equation 1 equation. Understand? Nothing is here. I have applied only the length formula for the first length. As I assume in the first case that this length was not brought here, now I have brought this length together. Now I will assume that this length is also available here. That means how many lengths total now? 2 lengths. Now if I consider 2 lengths, once I combine these two lengths, then image of the first length is going to behave as the partial object for the second length. This line remember. Once I combine this length with the first length, at the beginning I suppose that this length is not available here, but once I have brought this length in contact with L1, then this image of the first length will behave as the partial image for the second length, and then the image for the second length will be produced here. This is going to be the image for the second length. Let us suppose this is going to be I dash. Is that clear to you? Okay. This I was the image for the first length when second length was unavailable. When I brought this second length, then this image is going to behave as the partial object for the second length, and then the image will be produced here, I dash for the second length. This thing we have discussed in length maker formula, how it takes place, so I am not going to elaborate it now. Now again, now for the second length, you can write for the second length. For the second length, what will be the outcome? Again, same formula, 1 by f, that is 1 by f2 is equal to 1 by v. Let's be very careful when writing all these things or when we're putting this value. What is 1 by v in this for the second length? For the second length, this is L2, the image distance will be C2I dash. Am I clear? Image distance will be C2I dash. So I will write here C2I dash. 1 by C2I dash minus 1 by u. What is 1 by u? That is going to be your object distance for a second length, that is C2I. C2I, that is going to be number 2 equation. Let us verify again. 1 by f2, that is 1 by v, image for the second length, that is going to be C2I dash minus C2I, that is C2I, that is your object distance. And for the first length, similarly, 1 by v, that is going to be C1I is the image, and C10 is going to be your object for the first length. This is number 2 equation. Now, if I add 1 and 2, you can write adding 1 and 2 we find. Adding 1 and 2 we find. So if we add 1 and 2, now 1 plus 2 is implies. If I add number 1 equation, number 2 equation, what will be the outcome of it? Number 1 equation is, if I take like that, 1 by f1 plus 1 by f2 is equal to 1 by c1i, 1 by c1i minus 1 by c10 minus 1 by c10 plus 1 by c2i dash, 1 by c2i dash minus 1 by C2I minus 1 by C2I, like that I have added them. Now in this case, one particular thing I must tell you, when there was only one lens and these lenses were not available, then the image will format I. Once I bring this lens together with it, final image format I dash. So I can say that this is going to behave as I dash is going to behave as what? I dash is going to behave as final image for this combined lens. Okay, I dash is going to be the final image for the combined lens, and this is going to be the object distance for the combined lens. You please mind these two things. This is going to be your U and this is going to be the V. That means this is going to be object distance for a combined lens final combination, and this is going to be the P. That means this is going to be the image distance for the final situation, that means for the combined lenses. Remember, once I did combine this thing, then image will format here, but once I form them together, the image format here. So this is going to be final focal image distance, and this is going to be final object distance. So in this case, I have some assumption now. If I consider here a particular point, suppose this point is P, that means I am going to measure the distances from this point P. So I have assumed that this is the point P here. Now if I take this P point, so I can write what I can write here. I can write that C10, that you can write here, C10 is nearly equal to C10 is nearly equal to PO. Since this lens is going to be too thin, if we consider that lens is going to be too thin, then I can assume, or if I take a common point here to measure all the distances, then PO is going to be nearly equal to C10, and that is going to be your object distance. In similar case, I can consider that this C1I is nearly equal to PI. Is that clear? You can write. And C2I is nearly equal to PI, you can write. So you can write now, what you can write again, C1I, this is C1I, C1I is nearly equal to PI, you can write. Am I clear? Or also you can write the C2I dash, this C2I dash will also be nearly equal to PI dash. Understand? So I'll write now C1I is nearly equal to PI. Am I clear? Or directly you can write this case, you can directly write C1I is nearly equal to C2I. Is that clear? This is a very important point. C1I is nearly equal to C2I because this lens is going to be too thin, and this much of distance is of course negligible. And also you can write that this is PI dash is equal to C2I dash, also you can write, and that C2I dash is going to be, you can also write PI dash is nearly equal to C2I dash, and that is going to be behave as V. PI dash is nearly equal to C2I dash. Am I clear? PI dash is nearly equal to C2I dash. That means again you can write C1I is nearly equal to C2I. These are our assumption. So if they are equal, so then I can write that this is 1 by C1I and 1 by C2I will get cancelled. So what will be left? 1 by F plus 1 by F2 is equal to, I am writing this side now, 1 by C2I dash minus 1 by C10, I can write. This is implies 1 by F1 plus 1 by F2 is equal to 1 by C2I dash minus 1 by C10. Let us suppose This is equation number 3. Am I clear? This is equation number 3. Now again, from Lenz's formula, from Lenz's formula what we got? From Lenz's formula we got that 1 by f is equal to 1 by v minus 1 by u. This is number 4 equation. This is from Lenz's formula, we know it. Now comparing 3 and 4. Now from 3 and 4, what do you find? From 3 and 4 you can write, I have just missed out one lines in this case before writing this thing, I'm sorry. In this case a single line is left out. So this is 1 by f1 plus 1 by f2 is equal to 1 by c2 I dash. What is c2 I dash here? This is c2 I dash is going to be p minus c1o. This is c1o. So c1o is going to be your u. This equation will be number 3 equation. This is number 3 equation. Am I clear? Now from Lenz's formula you can write, from Lenz's formula what we got? 1 by f is equal to 1 by v minus 1 by u. This is equation number 4. Now comparing 3 and 4 you can write, comparing 3 and 4 we will get, if you compare 3 and 4 equation, we will get that 1 by f is equal to 1 by f1 plus 1 by f2, and this is going to be the equivalent focal length. This is going to be the equivalent focal length for a lens, for two lenses in contact. That means if you combine two thin lenses together, then the equivalent focal length will be expressed as 1 by f is equal to 1 by f1 plus 1 by f2. This is for only two lenses, those are in contact. And if I measure their power, the power will be similarly P is equal to what? P1 plus P2. But remember, this is for only two lenses. But if you consider so many lenses, then their focal length will be what? 1 by f is equal to 1 by f1 plus 1 by f2 plus 1 by f3 plus up to dot dot, it will be continue for so many lenses. And the signal power will be P is equal to P1 plus P2 plus P3 plus up to dot dot dot, like it will be continued. And this is all about the concept of two thin lenses in contact. If you combine two thin lenses in contact, or if you combine any two thin lenses, then what will be their equivalent focal length, what will be their equivalent power, like that we can find out. Any doubt, just inbox me and I'll write back to you. Thank you so much.